Hello, Vikings! It is your favorite math teacher coming at you with another live-ish lesson.
Okay, so here's something new and different. Parallelograms. Well, we've been talking about parallelograms. Parallelograms are a two-dimensional, that means flat, shape with the opposite sides parallel to each other. If the sides go up and down and side to side, the same distance, they're parallel. Cool. So like a square is a parallelogram and a rectangle is a parallelogram? Yes. What else is a parallelogram though? Okay, so these are both parallelograms. The square, the rectangle. They've got two sides parallel to each other and another two sides parallel to each other. It's easy to do when you've got right angles. Everything's a 90-degree angle. And so it just cuts out nice and even, the same size. But what about if the sides are angled? Well, that one is also a parallelogram. It's kind of like a rectangle that it's kind of squished. It's been through some things. It's seen stuff. This rectangle is no longer a rectangle, but it's still a parallelogram, even though it got squished. The two angled sides, they're opposite and parallel. The two other sides, they're opposite and parallel. How do we find an area for a parallelogram now? I'm glad you asked. Boom. Well, to be able to find the area of the square, since the sides are the same, you multiply one side times the other side. Doesn't matter which two sides. In the rectangle, it matters. You need to be sure and have the length times the width, or the base times the height. Same thing, just different names for the same thing. It looks a little like this. Like that. The area is the side times the side, or the length times the width, which is the same as the base times the height. Why would this be any different? Length, width, base, height, side, side, it's all same names for different things. It's two distances in opposite directions measured at right angles. This side, that side. Right angles, opposite directions. So how about this guy? How do we work that out? Well, the base across the bottom and the height measured at the right angle will give you the base times the height that you need for the area. What about those triangle bits at the end? Let me show you.
You know what's really odd? Every other number.
So I'm going to make a parallelogram, but I like it kind of long and skinny. So, it's just going to be easier for me. Honestly, that's what it is. I'm going to start it long and skinny, and I want to cut off one corner. Click, clack. There it is. That end's cut off. This is not a parallelogram because that side's not parallel. I could tape this one on. Instead, I'm just going to, there we go, cut that bit off so that it matches, using the piece I cut off as my guide. Ta-da! This is like purely a parallelogram. This side's parallel to that side. This side is parallel to that side. It's a parallelogram any way you want to look at it. So what's this base height business? Cool. Okay, I've got a parallelogram. Now I want to make it into a rectangle. Why did I make a parallelogram just to make a rectangle? I'll tell you why. Watch. I'll tell you why. We're going to make this parallelogram into a rectangle to prove the whole base height thing. Now, consider, if you will, this basic parallelogram. Yes, That means it likes pumpkin spice. I'm going to cut a piece off of it at a right angle. That's right, 90 degrees. Now, if you look, this is the piece I cut off down here. If I take that piece and bring it around and magically glue, fuse, tape, otherwise attach, it's now a rectangle. Those match up lovely, making 4 right angles. So it's the height and the base. The base is all the way down from one end to the other. The height is at a right angle, anywhere from one parallel line to the other one. Could be sideways. Could be this way. Could be that way. Any way you want to do it. Any way you want to do it. The parallelogram and its friend, the rectangle it makes, they can be combined using the area 1/2 base times height and find the area of either the parallelogram or the rectangle because they are the same shape. How cool is that?
Do you know why the equal sign is so humble? He knows that he's not greater than or less than anyone.
Okay, so here's a neat idea. Something that it's probably easier to show with rectangles, but we could do this with a lot of other shapes. Pretty much any shape, 3-dimensional, 2-dimensional, we can do this. Here we go. If you have a shape and another shape. Okay, so you'll notice as I put measurements on this, the scale is not perfect, but let's put some measurements to this. So here we are, 2x6, 3x4. They don't measure the same, but what's their area? Area is base times height. Let's do that. 3 times 4 is 12. But area is base times height, so 6 times 2 is 12. There you have it, people. It doesn't matter whether they're rectangles, triangles, or parallelograms. Squares are always squares, so it doesn't really work with them. But if it's different measurements, you can still have the same area. Way cool.
You know why 6 is afraid of 7? Because 7, 8, 9. Do you know why 7, 8, 9? Because it heard that 3 squared meals were important.